Hello, my name is Xinrui Chen and my net ID is XC856. This is question 2 for homework 2. The question shows that there is a noisy channel connect in series with the input and the output. The initial input is x1 and the final output is xk plus 1. Given that the probability of x1 equals to 0 is 0.2. The probability of x1 equals to 1 is 0.8 for all k larger than 1 and smaller than n. The conditional probability of xk plus 1 equals 0, assuming xk equals to 0, is 0.6. The conditional probability of xk plus 1 equals 1, assuming xk equals 0, is 0.4. The conditional probability of xk plus 1 equals to 0, assuming xk equals to 1, is 0.3. The probability of the conditional probability of xk plus 1 equals 1, assuming xk equals 1, is 0.7. For question A, we need to find the probability of x2 equals 1. The probability of x2 equals 1 is a probability that x2 equals 1 and x1 equals to 0 both occurred, plus the probability that the x2 equals 1 and x1 equals to 1 both occurred. According to the conditional probability definition, the probability that x2 equals to 1 and x1 equals to 0 both occurred equals to the conditional probability of x2 equals 1, assuming x1 equals 0, times the probability of x1 equals 0. The probability that x2 equals 1 and x1 equals 1 both occurred equals to the conditional probability of x2 equals 1, assuming x1 equals 1, times the probability of x1 equals 1, which is equals to 0.2 times 0.4 plus 0.8 times 0.7, which is equals to 0.64. And the method of finding the probability of x2 equals 0 is similar to this method. So we can also form a matrix to find the probability of x2. For question B, we need to find the probability of x3 equals 1. According to the question A, we could form the matrix to find the probability of x3 equals 0 and the probability of x3 equals 1. After the calculating, we could get that the probability of x3 equals 1 is 0.592. For question C, we should find the conditional probability of x1 equals 0, assuming x3 equals 1. In question B, we have found that the probability of x3 equals 0 and the probability of x3 equals 1, which is 0.408 and 0.592. The matrix can also be written as this, which is related to the probability of x1 equals 0 and the probability of x1 equals 1, so that we could find the conditional probability of x3 equals 1, assuming x1 equals 0. Here, which is 0.52. The question C has need us to find the probability of x1 equals the probability of x1 equals 0, assuming x3 equals 1. This is according to the conditional probability definition. The conditional probability of x1 x1 equals 0, assuming x3 equals 1 equals to the probability of x1 equals 0 and x3 equals 1 both occurred. Divide the probability of x3 equals 1, where the probability of x1 equals 0 and x3 equals 1 both occurred, is the conditional probability of x3 equals 1, assuming x1 equals 0, times the probability of x1 equals 0, so that the conditional probability of x1 equals 0, assuming x3 equals 1, should approximately equals to 0.176. For question D, we should find the limits of the probability of xn equals 0 as n approaches positive infinity. In the above questions, we could find the matrix of the probability of x infinity equals to 0 and the probability of x infinity equals 1. Therefore, the limit of the probability of the xn equals 0 as n approaches positive infinity should equals to 3/7.